So we're going to take what we did yesterday with the synthetic division, and we're going to build on that and use that skill to help us take a larger degree polynomial and break it down into its factors. And then once we get it down into its factors, it's easy to find the zeros or the x-intercepts, the roots. Those are all the same thing for that polynomial. So we're going to kind of baby step our way into it. So I'm going to tell you a factor right off the bat, and we're going to see what happens when that is a factor. When we do the synthetic division, we'll see something special happening. And then I'll say, okay, well, here's a zero, and then I'll take that stuff away, and we'll try to learn how to do this with just a polynomial given to us and no clues as to where to go with it. So hopefully we learn as we go here what's happening. So here's what we're going to do. We're going to take this one, and we've got x to the fourth minus 5x cubed plus 3x squared plus 15x minus 18. And I'm telling you that x minus 3 is a factor of that polynomial. So let's think about what's it mean to be a factor of, like, just say a number. What's it mean to be a factor of 12?
It multiplies.
It divides into it even. Like 4 is a factor of 12 because 4 goes into 12 evenly, right? So if x minus 3 is a factor of that polynomial, what's it mean about its division? It will have a remainder of, bless you. Okay. All right, so if we do the division with x minus 3, we should get a remainder of 0. And what will that do to the polynomial? It'll take it from a fourth degree to a third degree, which makes it smaller, right? So then that opens up some ideas of things we can do. So let's do that. And we're going to use synthetic division because x minus 3 is what? Linear, okay? So we're setting up the synthetic division for this. 1, negative 5, 3, 15, negative 18. What goes on the shelf?
3.
Positive 3, because remember we're setting x minus 3 equal to 0 to get that number that goes on the shelf, and it's just always the opposite number. And then we're going to do the synthetic division for that. Drop the 1 down, multiply 1 times 3, and then add. Multiply, add, multiply, negative 9, 6, multiply, there's 18. And what do you know? The remainder is 0. That's beautiful. That's why things go well. So what does that do? Well, what it does is it factors the polynomial a little bit for us into, instead of the x to the fourth power, we've got this factor that we just proved was a factor by getting a 0 as the remainder. And then the quotient here, that's going to be the other parenthesis. So what does this become? All right. And now we look at that and we go back to what we did a few days ago when we were factoring polynomials using some of the skills we already have. How could you factor this? Grouping, because it has what? 4 terms. Oh, man. First group together, what's the GCF of that group? X squared, leaving x minus 2. What do we pull out of the second group? Negative 3, that leaves x minus 2. And so we have x minus 3, x minus 2, and x squared minus 3 as the factors of that polynomial. There is our factored form for that polynomial. If I wanted to find the zeros of that polynomial, what do I do? All right, so to find the zeros, we would take x minus 3 equal to 0, x minus 2 equal to 0, and I don't know why I put that in parentheses, we don't need it. And then x squared minus 3 equals 0. And then, so we get x equals 3, x equals 2, and then x squared equals 3, and so x is equal to what? Plus or minus radical 3. Yeah, don't forget the plus or minus. Because how many solutions should we have for the zeros? 4, because the original degree of the polynomial was 4. Now, let's look at the graph of the original polynomial and see what's happening. So we're kind of trying to relate this all together. Everything we've done in this unit comes together in this section, or this particular lesson. So x to the 4th minus 5x to the 3rd plus 3x squared plus 15x minus 18. So that was the original polynomial that we had before we did any synthetic division or anything. So I hit graph, and look what's happening there. How many places is it crossing the x-axis? Try again. Is there a repeated zero? It's not a repeated zero. It's actually crossing. If you, that place where y'all think it might be bouncing, if you'll zoom in there, I'm going to zoom in there. You don't have to. Right there. Notice how it's going a little bit above the x-axis, so it's going there. So what's happening there, I'm going to back out to the regular view, is we're seeing it cross the x-axis. What would this solution be? Which is what? The negative square root of 3. That's where that's at. And then right here is a nice one at positive 3. Wasn't that one of our solutions we found? That's where it crosses the x-axis. It had a multiplicity of 1, so it crosses. And then where's the other places? Positive 2 right there. And when we zoomed in there, we saw it hitting positive 2. And then this other place is the positive square root of 3, where it's crossing the x-axis. All those things with the graph and the answers we found go together. Okay, so things we talked about with the multiplicities and the solutions when we did the graphs back the end of last week, that all relates back to this. We're just starting with a polynomial at the beginning. Let's do another one. Here's our polynomial. Let's say we had x to the 5th plus 5x to the 4th minus 15x to the 3rd minus 75x squared plus 56x plus 280. All right, so big one. We don't have skills to do 5th degree, right? We can't do grouping, all that. The X method doesn't work on that kind of thing. So we need to know a little bit of information. So I'm going to tell you that x plus 5 is a factor. So that means if I divide that polynomial by x plus 5, what's the remainder going to be? It'll be 0. So, and that will take that polynomial and break it down from a 5th degree into a 4th degree. So what goes on the shelf? -5. So the opposite, x plus 5, I'll give you a -5 on the shelf. And then you put 1, 5, -15, -75, 56, 280. Up there. Drop in and start working. -5. Hey, there's a 0. That's nice. And then there's -15 times -5 would be positive 75. There's another 0. That's nice. And there's a 0. That's 56. It's easy. And what do I know that 56 times -5 should be? -280, right? Because I know because they told me it was a factor that my remainder should be 0. But -5 times 56 is -280. So, all right. So let's look at what that did to the polynomial. It took that polynomial and it factored out an x plus 5. And then what's the other part? Plus 56. All right. So we end up with a trinomial in there. And we're going to try the X method on that. See if we can get that to work. Multiply to be 56, add to be negative 15. Negative 8, negative 7, right? So multiply to be positive. Both of them got to be the same sign. So that's going to give us x plus 5. And then, can I take the shortcut on those factors? Yeah, I got x squared minus 8, x squared minus 7. So there's the factored form. We want that. And then if we want to find the zeros, what do we do with those factors? Set them all equal to 0. And solve. So x equals negative 5. We knew that already. And then this one would be x squared is equal to 8. Should be x equals plus or minus 2 radical 2. This would be x squared is equal to 7. Should be x equals plus or minus square root of 7. How many solutions do we have? 5 of them. We got 1, positive 2 radical 2 is 2, negative 2 radical 3, or 2 radical 2 is the third one, positive radical 7, negative radical 7. That's 5 answers. The degree of the original polynomial was 5. Are all of these real numbers?
Yes.
Yes. So that means that this polynomial does what at negative 5? Crosses. At positive 2 radical 2. Negative 2 radical 2. Positive radical 7. Negative radical 7. All right. So we're going to see this polynomial cross the x-axis 5 times because all of those are real numbers. How about that? Okay. So if we graph that, we would see that happening. Get where I'm going with this? All right. It is. I enjoy this. It makes sense for it to come together like this. Yeah. Why did I write 5? That's supposed to be 3. Sorry. I can do polynomials, but I can't count. So, I can't count. I can do polynomials. All right, let's do this one. Let's do another 5th degree. X to the 5th plus 2x to the 4th minus 9x cubed minus 2x squared plus 8x. And I'm going to go ahead and give you a factor. X minus 2 is a factor. We'll get there. We're going to get there today in just a little bit. What if they don't give us something? No. Good. I'm glad somebody saw that. It has a common factor, so I could go ahead and factor that out and get it out of the way. Yeah, x is the greatest common factor, so I'm going to factor that out first and get x to the 4th plus 2x cubed minus 9x to the 3rd minus 2x plus 8. That's squared. Thank you very much. One mistake. Derailed the whole thing. All right. Now, here's once you factored out that GCF that we saw there, it makes it a little easier to do your synthetic division. Instead of doing the synthetic division on the big 5th degree thing, we can just do the synthetic division on that part. Because if x is a factor, we got it out of the way, and x plus or x minus 2 is supposed to be a factor, it'll still be a factor of what's left over there. It's kind of like 12. If 2 is a factor, there's still some other factors that go into 12 besides 2. 6 would still be in there. 3 would still be in there. That sort of thing. So we're going to do our synthetic on 1, 2, negative 9, negative 2, 8. The 4th degree part. And then, so what goes on the shelf? Positive 2. Drop it in and go to work. And what do you know? The remainder is 0. So now our polynomial has the x that we factored out at the beginning, and now the x minus 2 that we just factored out using synthetic division. And then what's this? X to the third plus 4x squared minus x minus 4. And that little jewel has what? Grouping that we could do. So let's do the jewel. You can't use that saying anymore. Jewels mean something else now. Sorry about that. It was, but it's not anymore. You guys have ruined it. Ruin anything. All right, so that's going to be x squared, x plus 4, negative 1, x plus 4. So that'd be x plus 4, and then x squared minus 1. But we know what about x squared minus 1? All right, so that's going to be x minus 2, x plus 4, x plus 1, x minus 1. So there is a completely factored polynomial. Oh, yeah, sure. It's too easy. All right, so we said x equal to 0. X minus 2 would give us x equals 2. X plus 4 gives x equals negative 4. Negative 1. Positive 1. That one's nice because all of those are linear factors. And we got how many of them? 5. The degree of the original polynomial was 5. Are all those real numbers? So that means this polynomial crosses the x-axis how many times? 5 times. Awesome. Good fun stuff. X to the 4th is 2x cubed. 64x minus 128. X plus 2 is a factor.
Yeah.
Hey, I don't play now. You didn't do an x squared. Silly man.
Well.
Now we're going to put a 0 in for it.
Oh. They generally do, yes. So is there GCF across the whole problem? You can kind of look for that. That's always a handy thing. So 1, 2, 0, negative 64, 128. Negative 128.
I'm just not going to add it on.
All right, so negative 2 on the shelf for this one. Drop the 1. There's a 0. That's nice. There's still a 0. That's nice. There's a 0. And then that's 128. And that's so we get x plus 2, and then what's the other factor?
Okay, you're going to get x to the third minus 64. Can't have any factors on.
Oh, wait a second.
Good. Difference of cubes in there.
Isn't it 4?
4 is the cube root of 64. So we're going to have short factor, long factor.
We got to solve this long factor.
Oh, yeah. All right, so that's, again, as Tilly said, that's x cubed minus 4 cubed, really. So that's x minus 4 for the short factor. What's the long factor?
X squared.
Okay.
Minus 16. Plus 16.
I thought you had this on this and
X squared plus 4x plus 16.
I keep on looking through this one. Oh my
Go to the bottom row.
Then we can X factor. X factor that one. Why can we do the only quadratic formula?
Why?
Because it's not a.
Because it came from a difference of cubes or a sum of cubes. It will never factor. So that means we're going to have 2 real solutions there. We got x equals negative 2 and x equals 4. That's from those first 2 there. And then when we said x squared plus 4x plus 16 equal to 0, we got to do quadratic formula. And so that'd be 4 squared minus 4 times 1 times 16. So that'd be 16 minus 64.
Wait, right now.
Yeah, that's right.
Oh, okay.
So this is the factored form. That long factor does not go any further. So that's the factored form. They're finding zeros now. 16 minus 64 would be negative 48. Is that right?
Too complex.
Ah, good. So we're going to have some complex solutions on this one. That's always fun. And so I'm going to break down the 48. 12 and 4, 4 and 3.
I can't break them down. I don't know why I can't, but
I don't know either.
Is this one gonna be 4, 3?
It would be negative 4 plus or minus 4i radical 3. See, I thought you couldn't do it. And then we're going to simplify that because everybody is divisible by 2. So that's going to be x equals negative 2 plus or minus 2i radical 3. How many times does this guy cross the? What do you mean? By grouping on the first? Yeah. Could have been done that way, yes.
And you didn't tell us?
No. But it would have worked the same way, right? It would have done the same thing. If we'd have done grouping at the beginning, it would have also got us a solution. The same solutions that we're getting here, we'd end up with the same factors. That's right. Good job. That's great to recognize that. So how many places does this graph cross the x-axis? 2.
Oh, because that's complex.
Because these are complex and those don't show up on the x-axis. Out of that. All right. So are we seeing a relationship between the graph and our zeros that we're finding? Okay. So that's the tie together for when you don't get a solution or a factor out of that. All right. So let's talk about how to get there when it comes to that. So the rational zeros theorem is what gets us there. Okay, the rational zeros theorem. It says the list of possible rational. What's it mean to be a rational number? Can be written as a fraction. We'll use P and Q to represent that. All right, P over Q. And the top part there are the factors of the constant from that polynomial. The bottom part, the Q, is going to be the factors of the leading coefficient. Coefficient coffee? You drink a lot of coffee?
No, I hate coffee, but that's
All right. So when we're making this list of rational zeros, these are the possible rational zeros. So if the polynomial has rational solutions, real numbers that can be written as fractions, then those answers will be in this list. Okay, and being able to make this list is somewhat important. We're going to use the graph to kind of help us after we make the list, but I want you to be able to make the list. So let's start with just making the list. So let's list the possible rational zeros. That's all we're going to do on these. We're not going to do anything else. We're on number 5. Here's our function. X to the third plus 2x squared minus 11x plus 12. Okay. So P over Q. We want the factors of the constant. Which one of those is the constant?
The one that doesn't have a variable.
The one that doesn't have a variable. That's
12.
The 12. So we need the factors of 12. So let's list out all the factors of 12. All right. 1, 2, 3, 4, 6, and 12. And technically, it's positive or negative on those as well. This one's a little easier because what's the leading coefficient? 1. So the only factors of 1 are positive and negative 1. Now, let's make the list from those factors. So the way you make your list is you take each individual factor from the top and divide it by each one of the factors on the bottom. So this one's easy because you only got 1 in there. So 1 divided by 1 is 1, 2 divided by 1, keeps going there. So your list is actually just the factors of 12. So plus or minus 1, 2, 3, 4, 6, and 12. So what we've done is we've narrowed down the possible rational zeros for this polynomial from every number in known creation to this list of 1, 2, 3, 4, 5, 6, 12 numbers. That if it has rational solutions, it's got to be one of these 12 numbers. Okay, that's what we're narrowing it down to, that using the parts of the polynomial. And then what we would end up doing is trying those in synthetic division to see which one give us the remainder being what? 0. That's what we're looking for there. Okay, so that's what we'll do the next step later on. But let's focus on getting that list first. No, only some of them will, if any of them do. Ooh, yeah. All right. 4x to the 4th minus x cubed minus 3x squared plus 9x minus 10. And we're just going to make the list. That's all we're doing on this one, is making the list. All right, so we want the P over Q. So factors of 10 goes on top. All right. On the bottom, factors of 4. Okay. So when we make our list, we got all of those divided by 1. And then we got all of those divided by 2. So 1 divided by 2 is 1/2. That's a rational number. 2 divided by 2 is 1. We've already got that one written. 5 divided by 2, we don't have that one written. So 5 over 2. And then 10 divided by 2 is 5. So I've already got that one wrote down. Okay. And then we go and we divide them all by 4. 1 divided by 4, that's a fraction, 1/4. 2 divided by 4 is 1/2. We've already got that one. 5 divided by 4, I don't have. And 10 divided by 4 is 5 over 2. So I've already got that one written down. So that is my list. 1, 2, 3, 4, 5, 6, 7, 8, 16 numbers that are possible rational zeros to that. So that's what we're looking for. If I ask for the list of the possible rational zeros, this is what I'm looking for. Is that list. Okay. All right. Questions about that? All right. Now let's go into actually solving a polynomial given nothing. Not giving you a factor, not giving you a zero at all. We just start from this. So we're going to find all zeros of the polynomial. And when I say zeros, I also mean roots, x-intercepts. They are the same thing. Okay, so zeros, roots, x-intercepts, they all mean the same thing. So if we're given this, we're on 7, aren't we? F of x is equal to x to the 3rd minus 8x squared plus 11x plus 20. we're given that polynomial, and they ask us to find all the zeros of that polynomial. We know the process is we're setting that whole polynomial equal to 0, but we're going to go through listing out the rational zeros, so that tells us where we can start. If there are any rational solutions, let's find out which ones they would be. So our constant term is, and our leading coefficient is 1. So that makes making that list easier, right? Because you know it's only going to be the factors of 20. So our factors of 20, we don't even have to do the fraction stuff for this one. So the factors of 20 are 1, 2, 4, 5, 10, and 20. So there are only 12 possible places that it could cross the x-axis as a rational solution. And back when I went through, everybody didn't have a graphic calculator, so we had to just guess and pick one and try. And if it worked, great. If it didn't, guess again and go from there. And you go through, and that worked fine. It didn't take that long. You pretty good at number sense back then, but we've got a little bit better technology now. You got the graphing calculator, so we're going to use it to help us, because we know the relationship between the zeros of the polynomial and the synthetic division stuff is that when it crosses the x-axis, that means if it's on one of those numbers, we can do synthetic division with one of those numbers, and the remainder would be 0. So look at the graph of this polynomial. All right, dollar store's got batteries. All right, so I've typed in the polynomial. I'm going to hit graph and look at where it's crossing the x-axis. Where is it crossing the x-axis, it looks like? -1, looks like +4 and +5. Okay, I'm going to check one of those. So I'm going to hit trace, and I'm going to check the -1, because ones are easy to do math with. And when I see the y value there, I hit trace and typed in the x value I wanted to check. And it gives me a y of 0. What that means is that will give me a remainder of 0 when I do synthetic division with that. So that's what we're going to do. -1, 1, -8, 11, 20. And let's break that cubic polynomial down to something we can work with. So 1. There's that remainder of 0. Okay. So right now, what's the factor that goes with -1 as it'd be x plus 1. Good job. And then what's the factor for this stuff here? And if I'm trying to find zeros, what strategies do I have for solving a quadratic? X method or quadratic formula? Okay. I'm pretty sure it does, yeah. 5 and 4 multiplies by 20, but you got to get the signs right. -5, -4. So that'd be x minus 5, x minus 4, and x plus 1. So we get the 0, we get the factored form there, and that gives us the zeros of x equals -1, x equals +5, and x equals 4, which directly relates to where it crossed the x-axis, right? They're exactly the same. It isn't. It really, it's just the put together of everything we've done with this whole unit. It just, I think you guys have done a good job with it. It's just got to put it all together here. Let's try this one. F of x is equal to x to the third minus 4x squared minus 15x plus 18. Can I?
take out x squared on one, no, you're not gonna get the same answer.
Right, because the other one, the GCF is a negative, you pull out a -3,
Yeah.
and that doesn't give you the same thing. Good idea, though. Anytime you can look for that and do that, that shortens things up, because factoring is probably a more efficient method than synthetic division is, right? So let's do the P over Q list, kind of narrow down our choices. And the good thing is the leading coefficient's 1, so all I got to know is the factor's 18. 9 and 18. So it's got to cross the x-axis at one of those 6 numbers. Or one of those 12 numbers, excuse me, positive and negative in there. So I'm set up my synthetic. 1, -4, -15, 18. And then I got to find something on the shelf. So how do I find out what to put on the shelf? Graph it. That's the third. Minus 4x squared minus 15x plus 18. Looks like it crosses in 3 pretty nice places. Pick your favorite. 1 would be my favorite. I'm going to check that one. Trace 1, enter. And it does give me a 0 on the y, so I know that that one works. Okay. I'm going to put a 1 on the shelf. Bless you. Run the synthetic. Hit zoom 6. -18. And there's that remainder of 0. And then this is x squared minus 3x minus 18, right? And then x minus 1 is that factor. So that we could factor that as x minus 6 and x plus 3. So we get the zeros of x equals 1, x equals 6, x equals -3. And if we look back at the graph, where was it crossing the x-axis? Exactly at those spots. And notice how these are all rational numbers and real, so it's crossing the x-axis. These are all in this list here. That all ties back together. Yeah, let's do one that's a little bit more fun. Yeah, more fun. All right, so we got 9. Let's go. G of x is equal to 9x to the 4th plus 3x squared, or cubed, excuse me, minus 30x squared plus 6x plus 12. What could we do with this one? Could do that. Or what could we do first? GCF of 3 would make those numbers smaller, which always makes life easier. So I'm going to pull out the GCF of the 3. It doesn't have an x on it, but it still just makes those numbers smaller, makes the math a little easier. So it's going to be 3x to the 4th plus x to the 3rd minus 10x squared plus 2x plus 4. And then I can do my P over Q list for 3 and 4 instead of 9 and 12. Much smaller lists there. P over Q plus or minus 1, 2, and 4 plus or minus 1 and 3. So that list would include 1, 2, and 4, 1/3, 2/3, 4/3. So this one's got some fractions that it could be out of that. And then set up a synthetic with this part, not the original. It really doesn't matter which one you do that with. You're just going to have bigger numbers if you use the original. You still should get 0 in the remainder, whether you use the original or the part that I'm using here. To graph it, it technically doesn't matter because we didn't factor out an x there, so it really doesn't matter. I'm going to go back to the original just so maybe if I screwed something up, I can catch it. I don't think we did, but just 9x to the fourth, 3x to the third, 30x squared, 6x plus 12. All right, I see it crossing the x-axis there at, looks like -2. So that's one I'm going to start with. So if I hit trace and -2, that's the one that's pretty obvious to me. So that's one I'm going to start with. Three, drop it down. Bless you. -6. Hold on. I copy everything down there. And then 0. And there's the remainder of 0. All right. So that brings us down to an x cubed from there. But here's what I want to show you. Just kind of another strategy. Instead of breaking that out and doing x method to try to factor it, let's look at other things that we could possibly do that would help us on problems that maybe don't do that factoring. So with this one, I see it crossing again right here at this place. And I could check one of my fractions from my list that I've got. So I had -1/3, -2/3, and -4/3. That really doesn't look like any of those because it looks like -0.5 close to that. But I could check those and see if it gets me that. So I'm going to check -2/3 because I think that would have the biggest chance. So -2 divided by 3. And notice I don't get a 0 on the y out of that. So that tells me -2/3 is not a 0 of this polynomial. So that's not going to work. So I look over here on the right, and it looks like it might be hitting the x-axis at +1. So I'm going to try that. So trace +1. And it is hitting at +1 because the y value is 0 there. So what that allows me to do then is do synthetic division again on this part with a +1. Okay. So what we're going to do is, because +1 is a 0, we can see that on the graph. We're going to take +1 and do synthetic division on this polynomial instead of doing the factoring. And that still get us the same answers, but it'll kind of get them in a little different way. Why do I have to? Because I'm trying to break the polynomial down as far as I can so that I can get all the zeros. Because I should be getting how many answers? And what's the degree of the original problem? 4. I've only got 1 so far. There's 3 more to get. So I've got to get them in some way. So what I'm trying to show you is a way that you can still get some of those even if they won't factor. This one, it would factor with the x method if you did well, actually, it'd be x cubed and x squared and plain. That wouldn't work. So you don't have that option. Yes, you would be able to. If you we started with -2, we broke it down to here. We're going to use 1 next. If you'd have started with 1, you'd have had a different set of numbers here, but it would have still worked the same way. You still do the same thing. Yeah, that's still going to be a factor. And then we're going to get another factor by doing the 1 with this one. Okay, 1 is a factor of the original polynomial, and it's also a factor of this smaller part of the polynomial because we haven't taken it out yet. It's kind of like when you divide 12 by 2, there's a 6 still left over, right? 3 will still go into that. So it's still a factor in there. So we're going to drop the 3. And there's that remainder of 0 there as well. So we've done synthetic twice. So the first time we did it, this red line here is x cubed, because we started with x to the 4th. Now this green line is going to be x to the squared, right? X squared. So this is a quadratic left. So we have those two factors. So x plus 2, x minus 1, and then we have 3x squared minus 2x minus 2. And all of that, we're setting each one of those equal to 0. If we tried the x method on this, we need something that multiplies to be -6 and adds to be -2. Is there anything that multiplies to be -6 and adds to be -2? No, doesn't work. So we're not going to do that. I've got to do quadratic formula now then. So -2 squared minus 4 times a times c. 4 plus 24 is 28. 2 real solutions out of that. I'm going to break down the 28. 7 and 4. 2 and 2. So a 2 comes out. So I have x equals -2, x equals +1. Those are the ones we used in synthetic division. And then I've got these real solutions, but they're not rational because I got that square root left in there. We're going to simplify that a little bit. Make it 2 plus or minus 2 radical 7 over 6. Yes, absolutely. All three of these numbers are divisible by 2, so we're going to divide them by 2. So 1 plus or minus radical 7 over 6. Or 1 over 6 plus or minus square root 7. 3. Thank you. Do polynomials. I just can't do regular math. So this one, we got 2 rational real solutions. These are real solutions, but they're irrational because they got the square root of 7 on there. This is the weird places that it was crossing the x-axis that we tried the -2/3 on. It didn't work. These two are the weird ones that are there. Yeah. Technically, it's there. Since it doesn't have an x, it really doesn't affect our zeros and all that. If I asked for the factored form, then yes, you would. But if I'm just asking for zeros, it really doesn't matter if it's there or not. Good question. Thanks. All right, let's. Some of them are long. It just takes a while sometimes to work through these, but it's doable. Let's look at this one here. Last one of the day. All right, good question. All right, somebody, Grace asked, well, how do you know how many times to do synthetic division? Look at the degree of the problem, and you generally are going to have to do synthetic division until you get it down to x squared. Okay, so if the degree is 5 at the beginning, how many times would you have to do synthetic division to get it down to x squared?
3 times.
3 times. If the degree is 4, you would need to do synthetic division twice. If the degree is 3, just once. Okay, so whatever the degree of the polynomial is, if you'll subtract 2 from it, that'll tell you how many times you could do synthetic division with it, most likely. Not always, but that's a good starting spot. Out of there. Degree minus 2 equals the number of times you might need to do synthetic division. All right. Okay, that would be helpful. So our factors would be x squared minus 25, x squared plus 3. So using factoring, That would be x plus 5, x minus 5, and x squared plus 3. And so that would give us x equals -5, x equals +5, x squared is equal to -3, which would be x equals plus or minus I radical 3. Because it's factoring, and factoring is fast.
Yeah. That was like a dad's joke. I don't want to.
All right, now, so factoring is fast, and it did work on this one. What if you didn't recognize that you could do the factoring on that? What if you saw that problem, you're like, you tried to do the X method, and you just didn't come up with the numbers? Get the P's and Q's, and the list of P over Q would be plus or minus 1, 3, 5, 25, 15. 15 goes into it 5 times, 25 and 75. And then we'd graph the thing, and we'd see it crossing the x-axis at +5 and -5. So you could start off with let's do -5. 1, 0, -22, 0, -75. If you did the synthetic, what should the remainder be? 0. So drop the 1 in. The 25. There's 3. -15. -15. 75. And there's 0. All right. And then we also knew that it crossed the x-axis at +5 because we saw it on the graph. And we go with the +5 on the shelf and do synthetic again because the degree was 4 to start off with, right? So if we do synthetic division twice, we should get down to a quadratic that we can solve. And then that's going to get us 1, that's a 5, that's a 0, that's a 0, that's a 15, and there's the remainder of 0. So we end up with x squared plus 3, which is the same factors we got by the grouping stuff. I'm sorry.
I chose not even to do that.
Yeah,
But here's what I want you to see. We've said this, everything that we've done this semester is there's more than one way to do it right. More than one way to get to Jackson. Your end result is the answers, right? There's more than one way to do it. If factoring is an option and you're good at that, knock it out. Go for it. Do it. If factoring doesn't work, you've got this other option. Sometimes the road is closed that you want to take. So you've got to go a certain way, right? If Highway 45 is closed and you're trying to get to Target in Jackson and they're working on the interstate like they are every stinking time I go up there, you've got to go somewhere else. You've got to go a different way. You have to go a certain way. When certain methods don't work, i.e. factoring doesn't work, you've got to go this method. But if factoring does work, you can go that route or you can still go this way. Okay, so being able to do that in different ways is important. Now, quick review on the graphs. What happens if the graph bounces off the x-axis? It has an even multiplicity, which means it works how many times in synthetic division? At least twice, right? So if it bounces off the x-axis, say at +2, then you could use +2 in synthetic division the first time, and then use it again the second time, if you needed to, okay? Keep that in mind, that if it has an even multiplicity, that means you can use that answer in synthetic division more than once. Here's the thing, if it doesn't work more than once, then you won't get a 0 as the remainder. Once it quits working, the remainder doesn't give you 0 again, okay? So keep that in mind as you're working through this thing.